In our previous tutorial, we learned how to implement a model in CPLEX OPL in compact form. But in that implementation, as you can see here, we have written all the data, input data of the problem into the model file. This is not the best way to implement a model in CPLEX OPL, especially if you want to solve different examples of the same problem. For example, in our previous tutorial, we modeled the same problem with first 10 product types and then 5 product types. And in order to change the model, in order to implement these two versions of the problem, we first created a model file with 10 products, and then we created another model file with 5 products. Okay, and in order to run these, in order to test these, we created two configurations. This is the configuration with 10 products, and this is the configuration with 5 products. By the way, initially we constructed the model by using these ranges at 1 up to 10, and later on we decided to adjust it. We decided to define these parameters. Let me do it for this first model as well. So in this example we have 10, and then let's change all these 1 up to 10 with the products. So both models will be the same. Okay, so why we don't like to write these parameter values into the model file itself, but we prefer to write them, we prefer to input the data in a separate file called the dot file. Because, as I said, if you want to solve different examples with different parameter values, but with the same model, same formulation, then if we write the parameter values into a separate data file, we never touch to this model file. Model file is always the same, and we just make modifications in the data file. So let's see how we can do this. Later on we will also see how we can read the data from an Excel file. And let me just remind you, this was the model that we implemented in CPLEX OPL, but this constraint over here, I have written this constraint to show you how you can refer to individual elements. Now I want to ignore that constraint. Okay, I will delete that constraint. I will use this version of the model, and in our CPLEX, of course, we will delete this this constraint. I'm doing this because we will solve different size examples, maybe with 3 jobs only, with 3 product types, 20 product types, and etc. So in those cases, that constraint which says that product type 1 plus product type 5 should be less than or equal to 3. So if you are solving an example with 3 products, then there's no product type 5. Okay, so in order our model to be more flexible, I just ignored that constraint. Again, let me delete this constraint over here. Now, as you see, we have 2 model files, one with 10 products and another with 5 products. But in both of these, the values of the parameters are inside the model file. In order to make this CPLEX read from an additional file, let's first create a data file. And in fact, we don't need to use these both models. Okay, we will need only a single model file. For that reason, I will use this model file. Okay, what do? I first create a data file. For that reason, on anywhere on the project, just right click and click on New and Data. And here we need to enter a file name. I will write, let's say, tutorial data. Okay, you can give any name, and the data file is created and it is currently empty. And what shall we do? In fact, I want to move any numerical value from this model file into this data file. So the first one is this. Okay, so I want to move this to the data file. Basically, what do we do? In the model file, I will not write this value of 5, but I want this CPLEX to understand that the value of this parameter will be read from a data file, and the syntax for this is like this. So we just define our end products as an integer, and we make it equal to, and then we have 3 dots plus semicolon. Okay, so you cannot put 2 dots here. It should be 3 dots and a semicolon. And by this way, CPLEX will understand that the value of this parameter is written in the data file. But where is it? It is currently empty, and the name of the parameter is n products. Okay, n products, and we basically set its value equal to 5, for example. And of course, like in the model file, all lines of the data file should end with a semicolon. And as you see, since we define this parameter as an integer here, we don't repeat it. We don't write int here. Okay, we just write the name of the parameter and its value. That's it. Okay, let's move to another one. So you see this p parameter over here. The values of the p parameter is here. I will just copy this part and then delete this part, and instead put 3 dots, and then in the data file, okay, I will just write these values with a semicolon. And similar to the previous case, you see we don't write this float over here. We already defined it. And also we don't write the size of the array. Okay, this product. We just say p, because the name of the parameter is p. This products over here, it is just the definition, the size of the parameter. Okay, then I will move all of these parameter values. Let me copy them and arrange them in the data file. Okay, I will move all of them here. The second one is t. Okay, and we will delete these, and then the third one is m. We just say the name of the parameter is equal to the values, and again some of the parameters, as you can see, are just single numerical values, but some of them are vectors or arrays, and they are defined here. And of course, if we will take their values from the data file, we should replace the values over here with 3 dots. And this one and this one. Okay, now let's save our files, the model file and the data file. And as you can see here in this model now, I don't have any numerical values. All of them are parameters, nothing numeric. But as you see, all numerical values are in this data file. Now let's solve this problem. Okay, as you can see, I have this configuration, and inside that configuration I have this model file. So if I just say run this to this model file, it will give me an error message, because in this model file I'm saying that you need to read this parameter value from a data file. But where is the data? Where is the data file? How will Simplex understand that the data is written in this file? Okay, for that reason, what do? As you can see, my data file is currently out of this configuration. So I need to drag and drop that data file into the configuration. And now, as you can see, inside my configuration I have a model file and I have this data file. Now when I right click, but as you can see, the error messages are still there, because you need to run it one more time to get rid of those error messages. So don't be confused that as soon as you copy the file all error messages disappears. No, just right click on the model file after making a change and run this. Okay, then when the Simplex runs, everything is correct. As you can see, you will obtain the solution objective function value. You can have a look at the x variable values over here. Okay, let me open this. Yes, x variable values and the objective function value. Okay, now what is the benefit of having a separate data file? Why don't we keep it inside the model file? Now assume that we want to solve another problem with let's say 10 products. So for that reason, what we should change in this model file to make it 10 products? As you can see, do we change anything here? No. Do we change anything here? Do we change anything here? Nothing to change in my model. The only thing that I need to change is my data file. I need to change this one to 10. I need to include new profit and time and material and demand values. Okay, so what do? In order to run the model with 10 products, create a new data file. If you like, of course, you can just you can just change this previous data file and then continue with it, or you can create a separate data file, give a name to that, and let me just copy the parameter values from my earlier model file. Okay, so and let's arrange these values. N products is 10, so we don't need this range. Okay, P is this much, the values, and then we have this T, M, and available time and available material. Okay, now this is the data file for 10 products and this is the data file for 5 products. So I want to solve this both of these separately. So what do? So what as you can see here, I have this model file with this data file which has 5 products. I want to use the same model file now with a product with 10 data. So you cannot copy 2 data files into the same product or it will be confused. Okay, therefore I will create another configuration, run configuration, give a name to this. Okay, let this be 10 products, 10 variables, let's say. Okay, now what do? This is my model file with 5 products. It is already in this configuration, but I will move it, or I will copy it into this new configuration as well. And as you can see now, the same model file appears in both of these configurations. But this time, instead of using this data file, I will use the data file with 10 products. Okay. And as you can see now, in this configuration, I have this model file with this data file, and in this configuration I have this model file with this data file. And since inside this model file there is no numerical values, if I use this data file or this data file, the same model file will be used to solve both of these instances. So let's just right click on this and click run this. Okay, so the Simplex solves it, and this is the optimal objective function value, and you can see the solution here as well. You see, we have the same model file with two different data files, and you can use as many data files as you like. You can create as many run configurations as you like, and in all of them you can use the same model file without any change, but you just change the data file, and that's it. Okay, this is how we communicate, or how we write the input the values of the parameters in a data file, and how we arrange the parameters or the run configuration so that our model file and our data file can communicate. Now let's assume that we have another model in which one of the parameters has two indices. As you can see in this example, all parameters have a single index. Now assume another model. I will not go into the details of this model, but assume that we want to minimize this objective function, summation I from 1 to, let's say, 10, and j from 1 to, let me change it to a smaller value just to show you, 1 to 4, Cij times Xij. Okay, this Cij, let's say, is a cost parameter. Okay, and this is the decision variable. And let's say subject to, we have this summation Xij, I from 1 to 4 is equal to 1 for all j from 1 to 4. And another constraint, we will see what model is this later on, but for now just we will concentrate on how to implement such a model in Simplex. Okay, and let's say Xij greater than or equal to 0 for all I and j. So as you can see in this model, I have just a single parameter, which is Cij. Also, I input the number of i's and j's into the model, but they are both the same. And I have a variable, decision variable, Xij. Okay, so let's go to Simplex and let me create a new project. Sorry, it will be a new OPL project. Okay, let me write tutorial. This is called assignment model. So I want to create a model, a default run configuration, and I want to create the data file as well. And let's just finish, and Simplex will create the run configuration, model file, data file for me, and the model file is here. Okay, so as I said, we have a single parameter which can take, let's say, integer values, and it will be C. Okay, but the C, I need the range 1 up to 4, but I will not write it in this way. Therefore, I will first create int, let's say number of jobs, okay, equals to, and the value of this parameter is 4, and I will read it from the data file. Another integer, this is the number of machines, so this model tries to assign the jobs to machines, and again I will read its value from the data file. Then I will create a range which is the jobs, and it will go from 1 up to 4, which is 1 up to n jobs. And I will create another range, so here I have two ranges, and this range will be machines, and it will go again from 1 up to n machines. And now I will define this C as jobs. Okay, you see now Cij, there are two indexes. The first index in these brackets, and the second index is in a separate brackets, and the second index is machines. Now it is very important so that the first index of C always denotes the jobs, and the second index denotes the machines. So this definition, C jobs and machines, is not the same with C machines and jobs. Okay, so the reference to machines and jobs are different. Therefore, you need to be careful about defining these and later using them in your model. Okay, again I will read the values of this parameter from the data file. So let's just go to the data file and define these parameters at the same time. Number of jobs is equal to 4. Number of machines in my example is equal to 4. Okay, let's write these. And also now I need to define the values of this C parameter, which has two indices, Cij. Now, how do I write these parameter values? Basically, this Cij, let me show it to you here. The parameter value is something like this. So this is job 1, job 2, job 3, job 4, and this is machine 1, machine 2, machine 3, machine 4. So in these columns we have machines, and in these rows we have jobs. And the value of assigning job 1 to machine 1, the cost of this is, let's say, 5. If we assign job 1 to machine 2, the cost is 2. Then we have 7 and 4. So as you can see, the values, the parameter values are given in a table. Okay, all other parameters we have written in a table. And how do we input it in this data file? So basically we use a curly bracket to represent the whole matrix, and then within this whole matrix we will write the individual columns inside brackets again. And the first column 5, 2, 7, 4, 5, 2, 7, 4. Okay, then we will write the second column, let's say 10, 3, 6, 8. The third column, the third row, sorry, is 5, 4, 4, 6. And the last one, okay, what is it? It is 2, 4, 7, 9. And as you can see, there is this bracket at the end and at the beginning, so it is the start and end points of the table, and each of these rows are also written inside brackets. And sometimes we write it in this way so that we can see the table as a whole, and this is the data file. Let's write the model file. Okay, so this is the parameter C, and let's define our decision variable X. Again, this is Xij, jobs and machines. And as you see, if we define C as jobs and machines, okay, we should also define X as jobs and machines. By the way, we forget the type of this X, so we can define it as a float plus decision variable. Now we can start writing our model. Our model is to minimize the total cost, which is summation. As you remember, there were double summation. And how do we write that double summation? Inside parentheses, I will say I in jobs, and then you can write sum, another sum, and then you can say J in machines. Okay, and then we will write Ci, sorry, not here, of course, Cij. As you see, I and J are written on different brackets, inside different brackets, multiplied by X, I and J. But of course, there is an easier way. You don't need to write these two summations separately, but you can just write both of them inside the same summation. So in this parentheses, inside the parentheses, we say sum I in jobs, and then with a comma J in machines, then Cij, Xij, and this is the same thing. Okay, when you have these two terms inside this summation, it is double summation like this in this model. Okay, then the constraints subject to, and we write the constraints inside these curly brackets. Okay, so let's have a look at the first constraint. When you are writing a constraint, first look at this right hand side. Okay, it is for all J. Okay, now I will write for all, then inside parentheses J in, it is not jobs, it is machines, J in machines. And then what's the constraint itself? It is the summation Xij, summation over I. Okay, so we say sum inside parentheses I in jobs, and then X, I and J, and this is equal to 1. Okay, this is the first constraint. And in the second constraint, the first look at the right hand side, I mean this index, it is for all I. So for all I, sorry, wrong parentheses, you need to be careful with the parentheses, brackets and curly brackets, all of them are different. I in jobs this time, then the constraint sum, again wrong parentheses, sum J in machines, X, I and J. Don't try to understand the model, just we are implementing this given model. Okay, it's just the implementation of this given model, and we will say that this is equal to 1. And as I told you, we never write these non-negativity constraints as separate constraints because it is already here. And now this is our model file and this is our data file, and let's see if we have any syntax errors, any type of errors, or is everything correct. To understand it, we need to run it. Right click on the run configuration that you want to run and click on run this. Okay, just waiting for the Simplex to solve the model, and as you can see, we got the solution, and it is optimal. Objective function value is 13, and you can see now this x value is given as a table, and of course you can have a look at its value from here, and again it's given as a parenthesis, but the thing is you need to look at the first element here, which is the value. The other ones are the so-called reduced costs and sensitivity ranges, and we are currently not interested in them. So it means that the first job is not assigned to first machine, not assigned to second, not assigned to third, but it is assigned to the fourth machine. As you can see, this is 1. And here we understand that the second job is assigned to the second machine, third job is assigned to the third machine, and fourth job is assigned to the first machine. This is how we read the result. But what I wanted to show you in this example is how to insert a model with 2 dimensions, a parameter with 2 dimensions into the data file, and also how do we define a decision variable and a parameter with 2 indices, and how do we use it in a model like this. Okay, so this is the second example for writing the CPLEX in a compact form and reading the data from a dot file. In the next tutorial I will show you how to read the data from an Excel file.